Friday, everyone. So we are in chapter 8, and so last week you were able to see a little bit of matrices, and today we're going to focus on the inverses of a matrix, and if we get a chance, we'll touch on determinants of a matrix. At any time, if you have any questions, feel free to put them in the chat or raise your hand, open your mic, and so let's get started. So the definition for a matrix is here, and basically what it's saying is that if you have a matrix A, and if you were to multiply it by the inverse, and the symbol for inverse is the exponent of -1, if you were to multiply it, then we would end up with the identity matrix. However, in order for this to be the inverse, you also need to be able to multiply A inverse times A. So whichever one comes first, it has to work in both directions, and it has to give you that identity. If that happens, then we say that A inverse is the inverse of A. Okay. So these are your identity matrices. Here's an example of a 2x2 identity matrix where all the diagonals here have a 1 in the diagonal, and everywhere else is going to be a 0. In the 3x3, notice in the diagonal we have 1s, and everywhere on top of that diagonal and below it are 0s. Okay, so here it says show that B is the inverse of A. So in order to do that, we need to multiply A times B, and we also need to multiply B times A. And if in both situations we get the identity matrix, then we can say that they're inverses of each other. Okay, so let's multiply A times B. So remember that in order to multiply matrices, the number of columns of the first one should be equal to the number of rows of the second one. So the order here is 2x2 and 2x2. And so that is the case. So we're going to take the first row, multiply it by the first column. So we get -1 times 1 is -1. And 2 times 1 is +2. And so if we add that, well, we'll add it here in a second, but if we add that, -1 plus 2 would be a 1. So that would be your first number here. But let's go ahead and multiply it out. So now we go to the next column. -1 times -2 is +2. 2 times -1 is -2. And there's no more columns, so we can go to the next row. So now the second row with the first column. So -1 times 1 is -1. 1 times 1 is +1. We go to the next column. -1 times -2 is +2. And 1 times -1 is -1. So if we add these numbers together, we get -1 plus 2 is 1. 2 minus 2 is 0. -1 plus 1 is 0. And 2 minus 1 is 1. So as you can see here, we have 1s in the diagonal, 0 everywhere else. So that's going to be the identity matrix. However, we can't say that they're inverses of each other yet. We have to continue by multiplying B times A. So if we follow the same procedure, if we multiply this row by this column, then we get -1 plus 2. And then this row times the second column, we get 2 minus 2, and so on. And you can see here, we're still going to get that identity matrix. So since they both give us the identity matrix, then we can say that B is the inverse of A. Okay, so that's how we would check if one matrix is the inverse of another by multiplying. So to find the inverse, which is what we want to do, there's different methods. Okay, so you have the first method on the left side where you would write your matrix and then you would attach the identity matrix. Then you would use row operations so that you could end up with the identity matrix on the left side, and whatever's left on the right side, that would be your inverse. Okay, so that's one method. Method 2 is to use this formula, but this only works if you have a 2x2 matrix. If you have something bigger than 2 by 2, then you would have to use the first method. There is a third method that if you're comfortable with the methods from chapter 7, solving systems, then this method might be worth looking at. And so if you're interested in looking at this method, I encourage you to check it out in your textbook so you can see an example of that. Okay, so let's do the first method. So it says find the inverse of A. So here's my A. And so what I'm going to do is I'm going to attach the identity matrix. So one's in the diagonal, 0 on the top and bottom of that. And then we're going to use row operations so that we can end up with something like this. So remember that when you're doing, in order to get to this right here, this first position here, we want it to be a 1. And in this case, it's already a 1, so we're good to go on that part. And then anything below it, we want it to be a 0. So remember, anything below the 1, we want it to be a 0. So since I have a -1, I know that if I add 1 plus -1, I would end up with a 0. Okay, so the row operation that we're going to do is we're going to take row 1 plus row 2, and whatever answer we get, we're going to put it in row 2. So in this case, we're not using, we're not changing the row 1, so I just copy it the way it is, 1, 4, 1, 0. And now if I add the rows, 1 plus -1, we get 0. 4 plus -3, we get 1. 1 plus 0, we get 1. And 0 plus 1, we get 1. And so we've met our goal of having a 1 in the diagonal and a 0 below it. So now our next goal should be to have the next diagonal part be a 1, which we already have it as a 1. So that means that we're good to go on that part here. So now I need everything above this 1 to be a 0. Since I have a 4, it would have been perfect if this 1 was a -4, because -4 plus 4 would have been 0. Since it's not a -4, what we can do is multiply -4 times the row 2 and then add it to the row 1, and whatever our answer is, we put it in row 1. So that's not going to change our row 2. We're just using it to help us change our row 1. And so let me go ahead and go to the next slide. So row 2, which is 0, 1, 1, 1, is going to stay the same. So 0, 1, 1, 1. Now I'm ready to take -4 times 0 is 0, plus 1 gives me the 1. -4 times 1 is -4, plus 4 gives me 0. -4 times 1 is -4, plus 1, -3. And -4 times 1 is -4, plus 0, -4. So if we look at our result, now we have 1s in the diagonal, 0 everywhere else. So I know that I'm done. So whatever is on the right side, that's going to be your inverse. So -3, -4, 1, and 1, that's going to be our inverse. Okay. So this is using the first method. The second method, and we're going to go ahead and use the same matrix. That way you can see which method you prefer. So the second method is using this formula. Again, the formula only works if you have a 2 by 2. And so in this formula, we're going to have 1 divided by A times D minus B times C. So that's going to be down here. And this number down here is actually our determinant, which is going to be for the next section. Then you want to switch the A and the D. We're going to switch them. So we would have D and A. And then for B and C, we're going to change the sign. So if it's positive, we make it negative. And this is positive, we make it negative. Okay, so let's go ahead and use the formula. And so we have, if it helps, you can label these A, B, C, D. So we're going to have, here's our formula. And then we'll plug in the information. So we're going to have 1. A is 1. D is -3. minus b, which is 4, times c, which is -1. I'm going to switch the d and the a. So a is going to go down here. So I get -3 and -1. We're going to switch the signs for b and c. So 4 is positive. Now it's going to be negative. And c is negative. So now it's going to be positive. If we simplify, we get 1 times -3 is -3. And then -4 times -1, +4. And we end up with a 1 here. So the 1 is a scalar, and that means that we multiply 1 into every number in the matrix. So 1 times itself, or 1 times this number here is going to be -3. 1 times -4, -4. 1 times 1 and 1 times 1 is 1 and then 1. So this is your inverse, and that's going to be the same result that we got with the first method. Okay, so these are the two methods that are most commonly used. The third method is I personally I like it, but it seems to be a little long because it's a system of equations. But if you're comfortable with system of equations, then that would be something that you might like as well. So let's find the inverse for these two examples here. And you can use whatever method you want. So we're just gonna use the formula since they're 2 by 2. So we have for the first one, 1 divided by a, which is 3, times d, which is 2, minus b, which is -1, times -2 for c. I'm going to switch the a and the d. So instead of 3 and 2, I'm going to have 2 and 3 now. And then I have to switch the signs for b and c. So instead of -1, I will have a +1. Instead of -2, I will have a +2. Then we simplify. So 3 times 2 is 6. -1 times -2 is +2. And we keep simplifying. 6 minus 2 is 4. And now we have a scalar of 1/4. So we're going to multiply that into each number or each element. So 2 times 1/4 is 2/4. 1 times 1/4 is 1/4. 2 times 1/4 is 2/4. And 3 times 1/4 is 3/4. So we reduce 2/4 is the same as a half. Then we have 1/4, a half, and 3/4. So that would be our answer. Okay, for B, we do the same. So we have 3 times 2 and -1 times -6. We switch our a and d, so we're going to have 2 and 3, and then switch the signs. So negative, negative become +1, +6. And we end up with 6 minus 6 and 1 divided by 0. We cannot divide by 0. And so what this means is that the matrix B does not have an inverse. Okay. So therefore, we say that B is not invertible. So I put an A here, but this should have been B inverse since we're working with the matrix is called B. So instead of A inverse, it should say B inverse and B inverse. So B is not invertible. So it doesn't have an inverse. Okay, so for this third one, again, we attach the identity matrix. At this point, if your instructor allows you to use a calculator, then you can find the inverse on your calculator. Otherwise, we would just do it by hand. And so what we're going to do is take this and try to make it so that we have the identity matrix on the left side. So my first goal is to have a 1 here, which I do. Now my next goal is I'm going to use the 1 to make the number below zeros. Okay. So the first thing I'm going to do is I'm going to multiply -1 times row 1. I'm going to add it to row 2 and then put my answer back in row 2. So it would look like -1 times 1 is -1 plus 1 is 0. So we would have 0 here. And then -1 times -1 is +1 plus 0 is going to be a 1. So this one here. And -1 times 0 is 0, plus -1 gives me -1. And -1 times 1 is -1 plus 0, -1. And -1 times 0 is 0, plus 1 is 1. And -1 times the last 0 is 0, plus 0 is 0. Notice that the first row didn't change and the third row didn't change. And so now we have the 0 that we wanted here. We're going to change the next one. So instead of, to make this 6 a 0, instead of multiplying by -1, we would multiply by -6. Let me see if I have that on the next slide. Yes, so -6 times row 1 plus the row 3. So we have -6 here times 1 plus the last row of 6 will give me that 0. And then -6 times -1 is +6, plus a -2 gives me that 4. And -6 times 0 is 0, plus -3, -3. -6 times 1, -6 plus 0, -6. And then last, -6 times 0 is 0, plus 0 is 0. And -6 times 0 is 0, plus 1 is 1. So now we have our 1 and we have zeros in the below it. So our next goal is to make the next diagonal 1, which we already have. And now we're going to use this one to make the top and the bottom zeros. Okay, and so in order to do that, we add row 2 plus row 1 since they're already opposite signs. So we're going to have 1 plus 0 is 1. -1 plus 1 is 0. 0 plus -1 is -1. 1 plus -1 is 0. 0 plus 1 is 1. And 0 plus 0 is 0. The second row stays the same. We're not changing it. And now for the third row, we want to make this 4 a 0. So in order to make it a 0, I'm going to multiply by -4 times 0 is 0, plus 0 is 0. And -4 times 1 is -4, plus 4 gives me a 0 here. And -4 times -1 gives me a +4, plus -3 is +1. And -4 times -1 is +4, plus a -6 gives me -2. -4 times 1 is -4 plus 0, -4. And -4 times 0 is 0, plus 1 gives me a 1. So we're almost there, guys. We're almost there. So the last diagonal is 1. We need the top numbers to be 0. And for this one, they're already opposite signs. So that's going to make it easier. We just add them together. So we're going to have 0 plus 0 is 0. 0 plus 1 is 1. 1 plus -1 is 0 right here. And 2 plus -1 is -3. -4 plus 1 is -3. 1 plus 0 is 1. And then the last, this -1, we add the numbers. 0 plus 1 gives me 1. 0 plus 0 is 0. 1 plus -1 is 0. -2 plus 0 is -2. And -4 plus 1, -3. 1 plus 0 is 1. So now we have all diagonals. All the diagonals are 1s and everything else is 0s. So that means that this part on the right side is our inverse. Okay, so what is the point of finding this inverse, right? Like, why are we doing that? So one of the reasons is we want to use the inverse to help us solve a system of linear equations. So you might be asking yourself, but we just learned several methods in chapter 7, right? Elimination, substitution, even graphing. So in chapter 8, you get to see 2 more methods, which is one using the inverse and the other one with the determinants. And so the other question that you might have is, but why do we need to learn this one, right? So in chapter 7, If you have three or less equations, then those methods are simple to use. But what if you had a matrix that was five equations and five variables, or even 10 equations and 10 variables? Then solving a system using substitution and elimination, it's still doable. It might just take a lot longer. And so with matrices, then we can make it a little bit quicker, especially if you have the technology involved, right? So um, we'll continue here. Let's see. So the systems of linear equations. In order to solve a system, your system is usually represented as AX is equal to B. And I'll tell you what these numbers mean, or what these variables or letters represent. So basically, A is your, well, we'll get to that on the next slide. But in order for us to solve for X, since that's what we're trying to solve is for the variables, then we can rewrite it as X is equal to A inverse times B. So A represents the matrix of your coefficients. X is just your matrix of all your variables. So if you have variables that are X and Y, that's where that would be. And then B is your constants, okay? And so you're gonna see that here on the next slide. So here's my system of equations, and we want to solve the system. Okay, so in order to solve the system using the inverse, you have to know what the inverse is. And so in this example, they already provide you with the inverse. And so we're gonna just write what A, B, and X are. So A, again, is the coefficients. So if you look at your system, in front of X, our coefficient is 1. In front of this Y, we have a -3. In front of this X, we have a 3. And in front of this Y, we have -8. So this is your coefficient matrix. B is your constants, in this case 4 and 12. And then X is going to be your variables. So we have X and Y. And now what we want to do is we're going to set it up as X is equal to A inverse times B. So here's my variable matrix. My inverse, they give it to me, which is up here, -8, 3, -3, and 1. And then I have my B. And so what we need to do is multiply. So -8 times 4 is -32. 3 times 12 is 36. So that gives me 4. And then -3 times 4 is -12. And 1 times 12 is +12. So that gives me 0. So our solution here is that X is equal to 4 and Y is equal to 0. And so that would be your solution. And let me go back really quick. And so sometimes, at least for my class, I do like people to write it as a solution set. So I would write my answer as 4, comma, 0, and then close your parentheses or your braces. Okay, so let's try another one. So the difference between this one and the one we just did is that they don't give me the inverse in this example. So it says solve the system using the inverse. So the first thing we should do is figure out what A, B, and X are. So A, again, is your coefficients. So we have 1, -5, 5, and -24, which we get from the numbers in front of X and Y. And then B is your constants, 27 and 128. And X is just your variables, X and Y. So in the formula, it says that we need to know what A inverse is. We don't know what that is. They didn't give it to us. So we need to figure it out. So we're going to use the formula since it's a 2 by 2. So we get 1 times -24 minus -5 times 5. We're going to switch A and D. So that's -24 and 1. Switch the sign. So -5 is +5. And +5 becomes -5. Okay, simplify. So we get -24 minus -25. Simplifies further. So we get 1 divided by 1. And so 1 times all these numbers are going to be those numbers. So my inverse is -24, 5, -5, and 1. So now I take my inverse, I plug it in here, and then my B, my constant matrix, I need to multiply. So negative 24 times 27 and 5 times 128. And let's see what we get. Okay, so then we're going to do negative 5 times 27 and 1 times 128. So if we simplify, negative 24 times 27 is negative 648 plus 5 times 128 is 640. We get negative 8, and negative 135 is for the second row, and 128, so we get negative 7. So my solution is going to be x is negative 8, and y is, let me just write it down. Oops. Let's see. So we would have x is negative 8 and y is negative 7. And so this would be my solution. All right, so let's go on. Now we have a 3 by 3. And so the idea is still the same, right? We use the inverse. And so they already give us the inverse, so that's good. A is going to be all your coefficients. So for the first row, we have 1, 1, 1. The second row, we have 3, 5, 4. And the third row, we have 3, 6, 5. And then our constants are 0, 6, and 3. And then our variables are x, y, and z. Plug it in. So my inverse, again, it was already given to us, times our constants. And so if we do the multiplication, we have 1 times 0, 1 times 6 is 6, and negative 1 times 3 is 3. So 6 plus negative 3 is 3. And then go to the next one. Negative 3 times 0 is 0. 2 times 6 is 12. Plus negative 1 times 3 is negative 3. So that gives us 9. And then the last one, 3 times 0 is 0. Negative 3 times 6 is negative 18. Plus 2 times 3, which is 6, gives us negative 12. So our solution is going to be x is 3, y is 9, and z is negative 12. Okay. Let's see what else is we have here. Okay, determinants. So the determinants, as we mentioned earlier, we have a matrix, and the symbol for determinant, it's either going to have it written as dt or these two vertical lines that look like the absolute value sign. That's a symbol for determinant. And so we take our matrix and we change it to these vertical lines since we're finding the determinant. And then to find the determinant, we're just multiplying a1 times b2, a1 times b2, minus b1 times a2. And so that would be your answer once you subtract. Okay, so let's try some examples here. So for A, find the determinant. So I have the determinant of A. And so here's my matrix. I'm going to multiply 2 times 2 and negative 3 times 1. 2 times 2 is 4. Negative 1 times negative 3 is 3. So we get 7. For letter B, same idea. 2 times 2 and 1 times 4. And so we get 2 times 2 is 4. Minus 4 is equal to 0. And so the determinant, remember, if you get 0, it just means it has no inverse. Okay, letter C. We got 0 times 4 and 3 halves times 2. So we end up with 0 minus 3, which is negative 3. Any questions on the determinant? Okay, so then the next one is the minors and the cofactors. So if you want to find the determinant for, let's say, a 3 by 3 matrix, and so we'll come back and talk about what minor and cofactor are here in a second. So if we want to find the determinant for this, again, if you're allowed to use a calculator, you can put this in the calculator and it'll give you your answer. Okay. If not, we can still do it by hand. So the first step is to find all the minors and cofactors. And so what you want to do is circle that first number, and we're going to cross out that first row and the first column. And so if you notice, inside after I crossed out, I'm left with a 2 by 2. So I can take that piece and I'm going to have -1, 2, 0, and 1. And so this one here would be my first minor. And we're looking at these two numbers represent the row and column. So since we crossed out the first row and the first column, then we're calling this M11 so that we can keep track of what we're doing, right? So -1 times 1 is -1, and 2 times 0 is 0. So my answer here is -1. So then if we go to the next number, I'm going to circle 2. And so I'm going to cross out the row and the column. You might want to refresh, Ruben. Yeah, okay. Um, we circle the second number, and then we're going to cross out the row and the column that it's located in. Since I crossed out the first row, that's where my 1 comes from. And I'm crossing out the second column. And so that's why we call this one M12. So the numbers that are left after we cross out are 3, 4, 2, and 1. And so we find the determinant of what's left, 3 times 1 and 4 times 2. And so we end up with 3 minus 8, -5. And then we keep going. So now we're going to circle 1. I'm crossing out that first row, third column. So I'm going to label it as 1, 3. The numbers left are 3, -1, 4, and 0. 3 times 0 is 0. 1 -1 times 4 is -4. So we end up with 0 minus -4, which is +4. And so we already did all the numbers on the row. Now we're going down on the column. So 3, I'm crossing out the the second row and the first column. So I call it 2, 1. And whatever's left, we find the determinant, in this case 2. And then we have, we can keep going, right? So the next one, same idea, 2, 2. Find that determinant of whatever is left. And so if we keep doing this, then we end up with all these minors, right? So the same idea, same process. So what you want to do is take all of these minors, and so I'm going to have them here. So the next thing we're going to do is we're going to find all the cofactors of A. And so the sign pattern for the cofactors are going to be positive, negative, positive, negative, positive, negative, and so on. Positive, negative, positive, positive. So what you want to do is you're going to see this is -1 times a positive, okay, is going to be negative. So now I'm going to call them, these are cofactors. So C11, negative times positive, negative. Okay, so I go to the next one. -5 times a negative is going to be a +5. And then the third one, 4 times a positive will be positive. And then 2 times a negative will be negative, and so on. Okay, so I get all of my cofactors, and we're almost done. So the determinant is going to be the sum of the entries in any row or column of multiplied by their respective cofactors. So for example, if we look at the first row, we have 0 times -1, because that's a 0 here is the first row. 0 times the first cofactor, -1. And then the second number for that row is 2 times the second cofactor of 5. So 2 times 5. And then the third one is 1 times its cofactor of 4. So if we add these, we get 0 times -1 is -1, plus 10 plus 4 is 14. And it doesn't matter which row you pick, you're going to end up with the same answer. So the determinant here would be 14. Okay. So in a little bit, if we have time, I can show you how to input it in your calculator. But the question now is, well, why do we care about the determinant? So again, our whole goal is to solve this system, okay? And so what you're gonna do is you need to get the coefficient matrix. So again, all the numbers in front of the variables. So A1, B1, A2, B2. So we're gonna have that here. And then you're gonna find the determinant of that coefficient matrix. And so that's why I changed it to the vertical lines here. Then we're gonna find the determinant called dx. And so for this situation, we replace the a1, b1 by the constants, and then we find the determinant. And then for dy, we replace the y's with the constants, and then we're gonna find the determinant. So your answer for x is gonna be dx divided by d, and y is gonna be dy divided by d. So for example, let's say you have this system and it says to use Kramer's rule. So Kramer's rule is this right here. Okay. So let's go back. So first thing is identify your coefficient matrix. So your coefficient matrix, you want to write down the determinant for that matrix, the dx and the dy. Okay. So let's go ahead and do that. So my coefficient matrix is 4, -2, 3, and -5. Again, these numbers are coming from the numbers in front of x and y. And if I find the determinant, we get 4 times -5, -2 times 3. So we end up with -14. Okay, so next we're going to find dx. So instead of a and b, a and a, we're going to write the constants. So our constants in this example are 10 and 11. So I'm going to replace the a's with 10 and 11. And the b stays the same. So 10 times -5 and -2 times 11 gives me -28. And then for dy, I'm going to replace the b's with the c's, or constants. So these are constants. And then we multiply 4 times 11 and 10 times 3 gives us 14. And now we're ready to solve the system. So x is equal to dx divided by d, and y is dy divided by d. So x is equal to -28 divided by a -14. So those are the determinants that we found. And so x is 2, and then dy was 14, and d was -14. So we end up with -1. And so that's going to be our solution to that system. Okay. So let me see if I can find my calculator in here really quick. Let's see. And then that way I can show you in case you are allowed to use a calculator. Let me see if I can find it though, because I changed computers. If not, we can maybe do like a word problem or something. I don't think I'm gonna have it. I don't see it. TI calculator. I can show you on Desmos, but usually instructors don't let you use like online stuff. But I can show you, that way you can check your work if you're using a like if you're doing your homework. I can't find my calculator on my computer. So let me share my screen. Let's see. Okay, let's go to Desmos. So you don't have to log in to use this, but if you go to Math Tools, you'll have a matrix calculator. And if you click on it, if we want to click a new matrix, just click New Matrix. Then here you can make it bigger or smaller. Okay. And then I'm going to enter just some numbers here. Let's say 5, 4, and 1. And I'm going to enter, that way it's kind of like in the program. So for decimals, you have your symbol for a inverse. So, oops. You want to put your matrix, and we called it A. So you just click A inverse, and then it'll give you your answer right here. If you click this, it'll convert it to fractions. If you want the determinant, you would click DET, then you put your A, and then you press enter, and it gives you your determinant. If you want to multiply two matrices, let me add another matrix really quick. Okay, I'm going to put it in the system. So if I want to multiply A times B, then the computer already has it in there, and it will multiply it. Or if you want to add, you can add them. And so this is helpful if you want to check your work. Now let's say you had a system, right? Let's say you had, I don't think I can write here. Let me just show you, that way you can see. Let me know if you can see my snippet. Can you see my, hold on. Okay, can you guys see my snippet?
Yeah.
Okay, awesome. So let's say that we had a system. So just ignore all this here. But let's say you had like 3x minus 2y equals 8, and x plus 3y equals 7. And you want to solve the system, right? So one we learned from the last week is if we write the augmented matrix, and this is 8. Okay. If you write this matrix, and then Ruben, if you want to take a picture of that just in case I forget the numbers, but I'll scoot it over here. If you want to solve this, then okay, so we have 3, -2, and 8. Then let's create a new matrix. So we have 2 rows and 3 columns. And I think I said, I forgot what I said. Okay, let me look. 3, -2, and 8. So we would enter 3, -2, and 8.
And 137.
1, 3, and 7. Okay, so that's your matrix. So we press enter. Now to solve this, you can use RREF, which stands for Reduced Row Echelon Form. And we put C, and it'll tell us the answer. If you want it in fraction, then it will look like this: 1, 0, 38, 11, 0, 1, 13, 11. But you have to know what this means, right? This is telling us that x is equal to 38 over 11, and y is equal to 13 over 11. Okay, so decimals can help you to check your answers. Um, Let me try one more time to find my TI virtual calculator really quick, and then if I don't find it, then I guess next time I'll make sure that it's in my computer. Yeah, no, it's not in here. I need to download the files. Okay, so I don't have. I think that was it. Unless you have any questions. Um, any questions that you might have? Okay, I'll pass it over.
Thank you, Ms. Chuka, for your wonderful presentation. We do want to remind you all about our previously recorded sessions, which are available on YouTube playlist. Today's session will be available on the playlist later on today. Also linked is a short survey to help us improve our TV sessions, so please take time to fill out the survey. We will be back next week with the Happy Math Hour, where Math 1314 and 1324 will be covering your final exam. Good luck to everybody. And before you leave, I just want to remind you that today at 1, we will also have the student success topic. And today will be the Rio Grande Border Health. Thank you all for coming in today. We hope that you all have a lovely weekend. If you have any questions, feel free to use the chat box or use the mic. And thank you all for coming in. Appreciate it.